Welcome back to the online classes. This is Zafarullah Mangi from the Department of Mathematics. We are going to start the topic sequence and limit of the sequence for class second year. So today we are going to start the topic sequence, the definition of sequence and why we use the sequence in the function topic. So here a sequence is a function. Actually we use a function topic, we are using the sequence. A sequence is a function. A is represent the function. We are already discussed about the function. F belongs to the natural number mapping to the real numbers. Same here, if we replace f and put here a, then it also represent the function, because a is the role model of a function. Okay, so here a is represent the function, n is a natural number represent domain, and when we put the inputs and its result will be in the given output in the sense of real numbers, either in positive, negative or neutral. Okay, so the image of or value of an, function of an of n belongs to the natural number. Here every point, every domain belongs to the natural number, because n is coming first. So that's why we can say that n is a domain, and here total n numbers which are belongs to the natural numbers is denoted by an. All the numbers are denoted by an, because if we put here n is equals to 1, because n natural numbers start from 1, 2, 3 up to so on. If we put here n is equals to 1, then it must be represent a1. It must be represent a1, because n represent 1. If we put here n is equals to 2, if we put here n is equals to 2, then here when we put here n is equals to 2, then it must represent a2. Okay, in the place of n we put here 2, then it represent the a2. Same here, if we putting different numbers of n from the natural number, then it represent this like sense, a1, a2, a3 up to an. Or you can say that this is an, because an here, and an is the function, n belongs to the natural values, means n represent the domain of the natural number, is denoted by an and called the nth term. This function or this sequence represent the nth term, or you can say that it's general term. There is two names of an. An you can say that it is nth term, because when we put here n is the last digit or last number of the natural number, then it must be represent or must be written in the form of an nth term. Or in other words, you can say that it's a general term. General term, you can, how can you can say that this is general term? General term in this sense, from starting to the last, from starting the ending point, all the numbers, all the sequence, all the functions are represented in the general form. When we put here first point, then it must be represent, it must be gives us that number which is putting the point. If we put the last number, then it must be represent that output or that image. So that's why we can say that this is general term of the sequence. A sequence is written either written as we can also write here in this form, a1, a2, a3 up to an, or you can say that a this is general term in middle brackets an. Okay, okay beta. So there is main point is there, this function, because this is the main reason when we applying the sequence of the function in limit sequence. So here an represent always be nth term, or you can say that in other words it's a general term. Okay, it must be start from a1. If n belongs to the natural number, it must be start from the a1, a2, a3 up to an. If n belongs to the whole number, then it must start from the a0, or you can say that a0. A0 is whole number because whole number is starting from the 0, and that's why this general term is start from a0. You can write in this sense a0. Okay, a0. But this point represent first element of the whole number. Okay, beta. So this is the sequence of a function, and function sequence why we use or why we use the sequence in function, because there is only one main point is that this is nth term or general term, and we find this general term in the sense of this function. Now the limit of sequence, this is the topic related to the sequence, and now we start limit of the sequence. Why we use the limit in sequence or in function? So limit actually is a approximate value or approximate point where we approach. So the definition of the limit of sequence is that let an I already explained that an, you can say that an is called the nth term, or other words you can say that this is general term. So let general term or nth term be a sequence let alpha belongs to the real number. Here alpha represent the limit point or approximate value which belongs to the real numbers, either positive or negative. If epsilon is negligible number which also belongs to the positive real numbers, and there exists n naught belongs to the natural number. Here n naught represent a point which is close to the 0 or negative or positive, such that, but here when n naught belongs to the natural number, it must be lying on the positive direction, such that modulus a n minus alpha less than epsilon. This modulus gives us two conditions. First one is in positive and other one is negative. I have already explained in the modulus function. The modulus functions depend upon two conditions, positive and negative.